Hi ABStat students. In Chapter 10, we're going to talk about comparing two different population proportions. So everything we've done so far has kind of led up to this moment, all these transformations and hypothesis testing. So this is where we actually look at running stats on two different things and making comparisons. Differences in context. So suppose there are two large high schools, each with over 2,000 students in a certain town. At school 1, 70% of students did their homework last night. Only 50% of students in school 2 did their homework last night. The counselor at school 1 takes an SRS of 100 students and records the proportion P hat 1 that did their homework last night. School 2's counselor takes a simple random sample of 200 students and records the population P hat 2 that did the homework. Describe the sampling distributions of P hat 1 and P hat 2. Well, P hat 1, first of all, is 0.7, and P hat 2 equals 0.5. We know that the shape will be normal if NP and N1 minus P are greater than or equal to 10, so we can do that. Well, P was 0.7 and times 100, because that was how many in the first sample, and that's greater than or equal to 10. And then 0.3 times 100 is 0.30. So this satisfies that condition, so we know that it's going to be approximately normal. If we look at P hat 2, this has 200 students. Well, 0.5 times 200 is going to be 100, so this is also going to be approximately normal. The center, remember, should be around my population center. P1 is going to be 0.7, right, based on our sampling distributions. P2 is going to be 0.5, right, a center of our sampling distributions. That's all the same. And our spread follows that same rule. So P1, 1 minus P1 over N1, all square rooted. And this would be the same with 2's. Now let's think about the difference in these two proportions. So if we subtract these two proportions, the shape stays the same. If we subtract one normal minus the other normal, it's still going to be approximately normal. The center P difference is just the difference in the P's. P1 minus P2. So this is going to be centered around 0.2, right? 0.7 minus 0.5, 0.2. So that's going to be our middle. And the spread, well, standard deviations don't add, variances do. Our difference is we'll have sigma 1 squared plus sigma 2 squared, all square rooted. So what this looks like is P1, 1 minus P1 over N1 square rooted and then squared, right? We square it, and plus, same thing with P2, and all of that is square rooted. Now what that works out to is this. And we'll work out that proof in class. So here's our sampling distribution. So the shape is approximately normal when N1, P1, N1, 1 minus P1, that's all for the first one, N2, P2, and N2, 1 minus P2 are all at least 10. The sampling distribution of the difference in P will be approximately normal. The center, the mean of the sampling distribution, is just the subtraction. You can subtract them whatever way, this difference. So the difference in sample proportions is an unbiased estimator of the difference in population proportions. So you remember what an unbiased estimator is. The standard deviation of the sampling distribution of P hat 1 minus P hat 2 is this. And again, we'll prove that in class. As long as each sample is no more than 10% of its population, so this is our 10% condition. Remember that always goes with our standard deviation. So here's an example. Your teacher brings 2 bags of colored goldfish crackers to class. He tells you that bag 1 has 25% red crackers and bag 2 has 35% red crackers. Each bag contains more than 500 crackers. Using a paper cup, your teacher takes an SRS of 50 crackers from bag 1 and a separate SRS of 40 crackers from bag 2. Let p hat 1 minus p hat 2 be the difference in the sample proportions of red crackers. So if we describe our sampling distribution, we have shape, center, spread. So our p difference is going to be p hat 1 minus p hat 2. So 0.25 minus 0.35 equals negative 0.10. Then we need to check that N1, P1, N1, 1 minus P1, N2, P2, and N2, 1 minus P2 are all greater than or equal to 10. So let's do that real quick. So we had 50 from our first sample times 0.25. That's greater than or equal to 10. And 50 times 1 minus 0.25. And that's good. Then we have 40 times 0.35 and 40 times 1 minus 0.35. So that all works, so we know our sampling distribution will be approximately normal. Cool, and then we need our spread. So our standard deviation of the difference, we're just going to type all of that into our calculator using that formula. So it's a big old square root. We have P1 0.25 times 1 minus 0.25, or you could say 0.75, all over 50 crackers, 0.35 times 1 minus 0.35 over 40. And I meant to say plus. So 0.246. So if we want to find the probability that the p difference is less than or equal to negative 0.02, well, we could write that. Probability of the p difference is less than or equal to negative 0.02. Well, I need to draw my sampling distribution. So I want this area, and I can use my calculator. Menu, stats, distributions. It's a normal distribution, CDF, from negative infinity to negative 0.2. And there's a 62.7% chance of this happening. So based off of our answer, would you be surprised if the difference in the proportion of red crackers in the two sample was equal to 0.02? And I would say no, it doesn't look that rare. Right? There's a 62% chance that we would get a difference that small or more, so definitely not significant. Then I can show you how to use your calculator for all of this. Okay, this is perfectly fine. It shows you know what you are doing. However, there is an easier way. Menu, statistics, stat, tests. This is a 2 proportion z-test. Well, we need the successes of our first one. Well, we know it's 25% red and there is 50 crackers. So 0.25 times 50. So this is 12.5. And then we also need the number of successes from bag 2. So it's 0.35 times 40. So 14. So we have 12.5 out of 50 crackers. And then we have 14 out of 40 crackers. And our alternative hypothesis is that, well, in this case, it's not quite exactly perfect, but we're going to say that P1 is less than P2. Because that's how we subtracted and we're going to get our negative numbers. This is typically how it's going to go. Don't worry, we'll do more in class. So now let's look at confidence intervals. I know I didn't do a great example, and I'll probably fix it for next year. Again, like I said, we'll do more in class. That gives you the gist. But let's look at confidence intervals. we need our three criteria. We need the random, the normal, and the independent condition. And this is our difference, p difference, plus or minus our critical value times our standard deviation. So it's all the same thing. So we need N1 and N2 to be random samples or random experiment. Okay, the data produced by a random sample in a randomized experiment. The normal condition is the same. N1, P1, N1, 1 minus P1, N2, P2, N2, 1 minus P2 are all at least 10. And the independent condition, both N1 and N2 are less than 10% of the population, 10% condition. So as part of the Pew Internet American Life Project, researchers conducted 2 surveys in the late 2009. The first survey asked a random sample of 800 U.S. teens about their use of social media and the internet. A second survey posed similar questions to a random sample of 2,253 U.S. adults. In the 2 studies, 73% of teens and 47% of adults said they use social networking sites. Use these results to construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. So we want to do a 2 proportion Z confidence interval. Okay, so we need random samples. So N1 and N2. So a random sample of 800 is our first one. And the second one is a random sample of 2,253. So there's both random samples. We need the normal condition. So N1, P1, N1, 1 minus P hat 1. Are all greater than or equal to 10. Well, 800 and 2,253, those are huge, so they're going to be definitely normal. So the sampling distribution is approximately normal. Then we need our independent condition. Well, 800 is less than 10% of all U.S. teens, and 2,253 is less than 10% of all U.S. adults. Okay, you guys can write all that out. Let's save time, and now we're just going to do it. Our calculator will do the rest for us. So we're going to be in confidence intervals and 2 proportion Z intervals. We need our successes and failures again. We were given percentages, so we have to convert it. So we need 73% of those 800 teens, and we need 47% of those 2,253 adults, and a 95% confidence level. So the issue is, when I'm putting these in, they need to be whole numbers. That one is fine, 584. The other one, this one we need to round. For this one, we could round up because it is so close. We can say 1059. So there's our confidence interval, 0.22 and 0.29, or 0.3. So we are 95% confident that the true difference in proportions between U.S. teens and adults who use social networking sites is from 0.22 to 0.3. Okay, we usually say it as we are 95% confident that the interval from 0.22 to 0.3 captures the true difference in proportions of all U.S. teens and adults who use social networking sites. Okay, both mean the same thing, it's okay. So what that means is it looks like teens are using more than adults, because if we're looking at the difference, remember that meant P hat of teens minus P hat of adults. So, since it was positive, we know that more teens are using social networking sites than adults, and that makes sense.